I'm Anil Kumar. Welcome to my series on discrete functions. In this video, I'm going to discuss with you a complete test paper on sequences and series. Our focus will be on arithmetic and geometric sequences and series, and we'll also take up recursive formula and general formula for different types of sequences. Here are 13 questions to share. These are from previous test papers, and I hope their solution will help many others. So have a good look at these questions. You can always pause the video, answer these, and then look into my suggestions. Now for some questions, especially question number 1, which is write the recursive formula for the general term Tn equals to 2n square minus 2n, I'll provide you with different types of solutions that will help you to adopt an approach which is good for you, right? So the other questions on this page, especially the 13th question, is right here before you. You can now copy these questions, solve, and then look into my solutions. So let's begin with the solution of the very first question, which is probably one of the toughest in this particular test paper. Write the recursive formula for the general term Tn equals to 2n squared minus 2n. So we are given a general term which is Tn equals to 2n squared minus 2n. When I say recursive formula, we have to write Tn in terms of Tn minus 1, correct? So one of the approach for this could be that you could just write all the terms, right? So starting with 1. So if I substitute 1 here, what we get here is 2 times 1 square minus 2 times 1, which is 0. And then second term will be 2 times 2 square minus 2 times 2. So that is 4 times 2, 8. 8 minus 4 is 4. Then we get T3 equals to 2 times 3 square minus 2 times 3. So 9 times 2 is 18, and from 18 we have to take away 6, so that leaves us with 12. Well, you can always use calculator in this test paper, right? So remember, the calculator is allowed, so you can definitely use calculator, correct? So, but wherever possible, you may avoid it, right? So it is n is 4 for us now, so we have 4 here. 16 times 2 is 32, and we'll take away 8, so it leaves us with 24, right? Let me go one more term here. So we get 2 times 5 square, which is 25 times 2 is 50, and we have to take away 10, right? So it becomes 40 for us. So that is how we could actually continue, and we get an idea of the different elements in this particular sequence. So what you notice here is that we have 0, 4, 12, 24, 40, and so on. Now, how do I get recursive formula from these terms? That is a real big question, correct? So you can do trial and error, or what I would like to do here is go with first and second difference, right? So we could actually do first difference and second difference. So whenever you have a sequence, it could be linear if the first difference is constant, correct? If the first difference is not constant, then it is quadratic. It could be a polynomial, but we know that here we have the first difference because that is the general term. So the second difference is constant, right? So it is a quadratic for sure, as you can see here. Now, what we could do here is rewrite these values as combination of previous term and the new term. What I'm trying to say here is we know T1 is 0, right? T1 is 0. Now T2 is 0 plus what? T2 is 0 plus 4, correct? That is how you get 4, and then you get 4 here. Now, to get T3, I have to begin with 4, and what should I add to 4 to get 12? It is 8, right? So that gives us 12. And then here, we'll begin with 12, and what should I add to 12 to get 24? It is 12 indeed, so we get 24. Now, to 24, what should I add to get 40, right? So it is 16, and that is how the process is going on. Do you see this part? So what you see here is that where this term is t n minus 1, right? So n minus 1 plus what is what our recursive formula is, right? So we figured out that previous term times we have to add, for the second term we have to add 4, for the third term we have to add 8. Now how do we get this? So one of the ways which we can think about is, these are all multiples of 4, right? These are all multiples of 4. Okay. Now, 4 times what is 4? 1. 4 times what is 8? 2. Now, 2 is 1 less than 3. So, therefore, we could write this as n minus 1. Do you get an idea? So, now here, we can now write down the recursive formula. Okay. So, we can say that recursive formula could be like this. So whenever you write recursive formula, you have to write the first term, and we say the first term t1 is equal to 0 and tn equals to tn minus 1 plus 4 times n minus 1. Is that clear to you? So that is how we will get the solution of this particular question. Now this is one approach. The other approach could be that we could do, let me write down here, method 1. Now let's do method 2. Now we could figure it out, correct? So it is always possible to figure this out, no problems. But here is a general method. Since you want tn minus 1, we know that tn is given to us as 2n square minus 2n. So what is tn minus 1? Let's figure this out. We have to replace n with n minus 1, right? So we get 2 times n minus 1 whole square minus 2 times n minus 1, right? We could have simplified also and then done it, okay. So now, okay, so basically we have 2 times n minus 1, and if I take within the bracket, I get n minus 1, and this is minus 1, correct? Because we have taken 2 times n minus 1 in the bracket. So we get 2 times n minus 1 times n minus 2. Anyway, we have to expand. So let us expand. We get 2 times n is n square, and minus 2 n, and this is minus n, and this is plus 2. So we do get something like 2n square minus 4n minus 2n plus 4, something like this. So when you expand, you may or may not do these steps. Finally, you get this. Now, see, tn is 2n square minus 2n. So from here, this 2n square minus 2n is a part of tn, correct? So we could combine these, right, and rewrite our expression as 2n square minus 2n. And here we are left with minus 4n plus 4, correct? So these two terms are tn. Do you see that? So we could now write this as tn, and here, well, we can take 4 common, right? So if I take plus here, so we can take minus here common, 4, right? So we get what? We get n minus 1 here, correct? So Tn minus 1 is Tn minus 4 times n minus 1. So let's rearrange this formula. So when you rearrange, you get Tn equals to Tn minus 1 plus 4 times n minus 1. Is that clear to you? And of course, we have to write down what is the first term, right? So when I substitute T1 will be equal to 0. Since I substitute 1 here, I get 0. So you could actually get your formula by substituting n minus 1 and then rearranging your terms. Right? So this is a general method which can be adopted whenever you are given a general term and you want to find a recursive formula. So I hope that makes sense. So finally, we do get our answer, and we can write down the answer, which is Tn equals to Tn minus 1 plus 4 times n minus 1, where T1 is equal to 0, correct? So that is how you can adopt any one of these methods and get your result. So I hope the concept is absolutely clear. Now let's move on and take the next question. Question number 2. Write the general term for recursive formula T1 equals to minus 4 and Tn is 2 times the previous term. So 2 times the previous term indicate that it is a geometric series, right? So we are given T1 equals to minus 4, that is the first term, and the next term Tn is represented as 2 times the previous term, Tn minus 1, right? So if you could identify that this is a geometric series, right? So we can know this is geometric sequence. In that case, you know what could be the general term, right? So general term will be, you can always write that as Tn equals to a times r to the power of n minus 1, where a, the first term here, is minus 4, right? And r is 2. Right. So that is how you could get a general term in this particular case, okay, from a recursive formula. Now, if that is not, very obvious, in that case, what you could also do is you could write your series, right? T1 is given to us as minus 4, and Tn is equals to 2 times Tn minus 1. So just multiply this by 2 to get the second term. So second term will be 2 times minus 4, which is minus 8. Third term will be 2 times minus 8 to get minus 16. And fourth term will be 2 times minus 16, which is minus 32. And now from here, you can see that the first term, a, is minus 4. Second is this. So this is a geometric sequence. Now, since it is a geometric sequence with the first term as minus 4 and r, the ratio 8 over 4, both negatives cancel, equals to 2. You can write the general term Tn equals to, minus 4, right? So first term is minus 4. So minus 4 times 2 to the power of n minus 1. Doesn't make sense. So that becomes our solution for question number 2. Perfect. Now let's take question number 3, which is, we are given that T3 is 19 and T15 is minus 17 in an arithmetic sequence. Find T47, right? So we have an example of arithmetic sequence. Now in arithmetic sequence, you know what is nth term, right? You can write Tn equals to a plus n minus 1 times d. That is arithmetic sequence. Now, when you are given that T3 equals to 19, we could write this T3 as a plus 3 minus 1 times d, or we can say 19 equals to a plus, this is 3, right? So this 3 minus 1 is just 2d, correct? Now for T15, which is given to us as minus 17, we could write this as a, which is, we need to find a and d, plus 15 minus 1 is 14, so we can write 14d. So we basically get two equations from here, equation 1 and equation 2. And from these two equations, we can always find A and D. So if I do equation 1 minus equation 2, then what do I get? So this minus this, that gets added up. 9 plus 7 is 16, and then 36 equals to A and A cancel. And 2 minus this gives us minus 12D, right? So that means D is equals to 36 over minus 12, which is basically equal to minus 3. So we get the value of D as minus 3, correct? Since D is minus 3, we can now find A by substituting in any one of our equations, correct? So we could use equation 1. So we have 19 equals to A plus 2 times D, right? And we know D is equals to minus 3. Substituting, we get 19 equals to A plus 2 times minus 3, or 19 plus 6 is A, which is 25. So we get A is 25. Now we need to find what T47 is. So T47 will be equal to A plus n minus 1 times D. Since n is 47 and we know A is 25, so we can write this as 25 plus 47 minus 1, and D is minus 3 for us, correct? So we get this as 25 plus 46 times minus 3, which is 25. You can use calculator, right? 6 times 3 is 18, and 1. 3 times 4 is 12, and 1 38. And that gives you a negative number when you take away 3, and then this is 1. So we get 113 as T47. Clear? So that is how we could actually answer this particular question. And now let's move on and take the next question, which is question number 4. We need to now write a general term for minus 3, 15, minus 17, 3, 75, and so on. So what you notice here is, let's work out the ratios, right? Let's work out these ratios. So we have 15 over minus 3, which is equals to minus 5, right? The second ratio is minus 75 over 15, which is also equal to minus 5. And the third ratio, 375 over minus 75, is also minus, right? And 5 times this, just try it out. 5 times 7 is 35. It works, right? So we basically have a geometric sequence where A is minus 3 and R is equal to minus 5. Correct? So since it is a geometric sequence, we can write that the general term is A times R to the power of n minus 1. We need to find the 8th term, right? So T8 will be equal to minus 3 times minus 5 to the power of 8 minus 1, correct? And this can be calculated using the calculator. So we have minus 3 times minus 5 to the power of 7, correct? So let's use calculator to figure this out. We know this is going to be negative, and negative times negative is going to be positive. So let's write positive here. So we'll do 5 to the power of 7 and then multiply this by 3. So we get a very big number, which is 234375. So that's the number which we get. So let's write this down. So we get 234375. Is that clear to you? Correct? So that is how we are going to get this solution. So I hope all the steps are absolutely clear, right? Let's move on and take the next question now. Question number 5. For the arithmetic series minus 40, minus 25, minus 10, plus 5, plus so on, find the sum of 52 terms. So we are now talking about arithmetic series, and we know A is equal to minus 40, correct? D, the common difference, is difference between the two. So you could see difference between any two of them. So if you do that, what do you get? So here we can take up any terms. So we have minus 10 minus 25, for example, between these two terms. So it is equal to minus 10 plus 25, which is 10 minus from 25 is 15. And we can also check that this difference is indeed constant. 5 minus 10 is 5 plus 10, which is also 15, correct? So the common difference, D, is 15, right? Now we need to find the sum of 52 terms. Now whenever you have an arithmetic sequence, then sum of n terms is equal to n over 2 times 2a plus n minus 1 times d, right? So that is the formula. Now here we know all the terms. We need to find S52. So S52 will be equals to 52 divided by 2 twice a is minus 40 plus 52 minus 1, and d is 15 for us. So we have half of this, which is 26 times minus 80, and this is plus 51 times 15. So let's use calculator to figure this out. So we have 51 times 15, and from this we'll take away 80, and then we'll multiply this by 26 to get our answer, which is 17810. Correct? So that is how we are going to find the solution of this question. So this is a straightforward knowledge-based question on arithmetic series sum. Okay, question number 6 here is, for the geometric series, now we are given a geometric series, we have to find sum of 7 terms, right? So since we are given geometric series, we can actually find the ratios direct away, right? So we know A in this case is 100. R is the ratio of the two terms, so it is minus 50 over 100, which is minus half. You can check with 25 and minus 50 also. So every term is negative half times the previous term, right? Now sum of series formula for the geometric series is A times. Now whenever R is a smaller number, you normally write this as 1 minus R to the power of n, right? So that is what we do. Normally we write 1 minus R to the power of n over 1 minus R, correct? So that is what the formula is. We need to find sum of 7 terms. A is 100 for us. 1 minus R. R is minus half to the power of n, which is 7. We have 1 minus R, which is minus half. Correct? So that is how we can write it down. So we can now use calculator to figure this out. Anyway, let me simplify this. So minus 7th power will be positive. So let me write 1 plus, and we'll have half to the power of 7, since the negative will remain negative when we have odd power, correct? So that is all. And 1 plus half is 3 by 2, right? Or 1.5, we can write 3 by 2. Okay, now use calculator to find this answer, which is, we have half to the power of 7, say 0.5 to the power of 7, and then we'll add to this 1, and then we'll multiply by 100, and then divide by 1.5. In decimals, this is equal to 67.1875. Okay. So that becomes the sum of 7 terms, correct? Let's move on and take the next question now. Question number 7. Find the sum of the series 4 plus 11 plus 18 plus so on till 88. Now here we have to do two things. First, figure out what type of series is this, and second, number of terms. So if you see this difference, 11 minus 4 is 7, and this is also 7. So this is a arithmetic series. Okay, and the nth term is 88, so we can find n from here, correct? So we at least know two things about it, that A is equal to 4 and the common difference D is equal to 7. Now we have to find the number of terms in this particular series. We know the formula that Tn is A plus n minus 1 times D. So Tn is 88, so 88 is equal to 4 plus n minus 1 times 7. So we can write this as 88 minus 4 divided by 7 is equal to n minus 1. So let's do this. So we have 88 minus 4 is 84, and when we divide this by 7, we get 12. So we have here 12 equals to n minus 1, or 13 is the value of n. Correct? So we know all our parameters now. That is to say that A is equal to 4, D is equal to 7, n is equals to 13, and we need to now find the sum of the series. So we're looking for sum of the series, and the formula for sum of the series is, it's an arithmetic series, so n over 2, 2a plus n minus 1 times d. You could also use t1, and we'll use alternate formula also to find this, correct? So now, for now, I've written this. So we have n is 13, 13 over 2 times 2 times 4 plus n is 13, 13 minus 1 times d, which is 7 for us. So let's figure this out. So we have 12 times 7, we are starting from here, plus 8, and then we'll times it with 13, and then divide by 2. So we get this answer as 598, right? So that becomes the sum. Now, for the sum of the series, the alternate formula is pretty good in this particular case. So let's see the alternate solution also. So the alternate formula for the sum of the series will be Sn equals to t first term, which is t1, and plus the last term, tn, times half of number of terms, right? So that becomes a general formula. We can always use this to find the sum for our 13 terms. So we have sum of 13 terms, in this case, equal to, first term is 4 plus 88, right, times n is 13 over 2, correct? And let's figure this out. So we have 88 plus 4 equals to times 13 equals to divide by 2 is equal to 598, right? So the other formula is pretty good when you're given the first and the last term. So I hope that makes sense. Let's move on and take the next question now. Question number 8. Find the sum of the series 2 plus 6 plus 18 plus so on till 1458. So first thing is identify the series. So we can see that the first term A is 2. And now how do we get the next term? Times 3, right? So it is a geometric series, right? Where we have first term as 2 and it is a multiple of 3 each time. So that is 6 divided by 2, 18 divided by 6 is R, which is equal to 3, right? So how did we find this? 6 divided by 2 and then 18 divided by 6. So all are equal to 3, right? So we are assuming this to be a geometric series. Now we need to now find what is this term number. So in a geometric series, to find the term number, we have the formula, which is general term Tn is equals to A times R to the power of n minus 1. Now nth term is given to us as 1458. A is 2 for us and R is 3. So we can divide 1458 by 2. We get 3 to the power of n minus 1, and that is 7, and 7 2 and 9, 729. 3 to the power of. So we have to look for what power of 3 could be 729, correct? We know 3 to the power of 4 is 81, and if I multiply 81 by 9, so it means 4 plus 2, right? So that will give us the power of, so we could write 729 as, we can check this out, right? So 729 is equal to what? Seven 29 is 3 to the power of 6, right? So it is 3 to the power of 6 is equals to 3 to the power of n minus 1, correct? So from here we can find the value of n. So we have n minus 1 equals to 6, or n equals to 6 plus 1, so we get n equals to 7, right? So now we know what n is. So once we know what n is, we can find the sum of the series using the formula, correct? So now let's find the sum of the series. The formula for sum of the series is S of n equals to a times r to the power of n minus 1 over r minus 1, right? So we want sum of 7 S7. So a is given to us as 2, r is 3, right? So 3 to the power of 7 minus 1 over 3 minus 1, correct? So that gives you 3 minus 1 cancels, so you get 3 to the power of 7 minus 1, and 3 to the power of 7 will be, basically, let's multiply 720, let's calculate. So we have 3 to the power of 7, and then we'll take away 1 from here. So we get 2186. So our answer here is 2186. Is that clear, right? So that is how you could actually solve such a question.